Hey guys, welcome to a new video. Today we'll be doing episode 4 of our database ER diagram of our Yummy app. So we're gonna continue where we picked off from last time, and it's gonna be around our database schema mapping. One of the things that I was thinking that we could do is we could have a user table. I did say we won't have user authentication, but I think I will have a form of user, just a user. So there won't be any password checks, or I guess we could have one later on, but we'll leave it as big serial as I don't imagine we'll have that many people. One of the user things is we'll just have a name and a username. They're both gonna be strings, but this is gonna be unique. So basically, if you enter a username, you'll be able to log in to anyone else. There'll be no form of authentication. I don't know if this is a good idea, but just thinking how there won't be enough people. This might work, maybe, just given the fact that there won't. Yeah, I guess. I guess just because you never know what might be good. We could have a string. This will be sorted when we do get to it in an email, which would be a string, which has to be unique as well. I did say there's no user auth, but these two will be optional. For now, just for the MVP, and then we can get to it later. But the name and username, where the username is unique, the name will be the display name. So that's how people, just because one of the things that I do want to do is I want to have a default country that the users are able to set. The default country, which is going to be an int, and this is going to lead to this. So let's see, what is this? That the user must have, the country can have one, can have none or many, but the user must have one and only country that they are related to. Cool. Just add that in before I forget it. Now let's come back to here. So we have a store, a country, a user over there. A store can have multiple menus, but a menu must have one store. Store can have multiple menus. Is that what it means? A store can have multiple menus. No, that doesn't make any sense. Store must have only one menu at a time where the row is for that store, because this store int points towards that. So one and only. So they're both. So menu can only have one and only one store. That makes sense. Yeah, we'll do it that way. Even if there's a duplicate row within the menu, it'll be easier to change in the future, I believe. And our store can only have one menu as well. Price. I don't think we actually need a price separate for that. We can just have it here in the menu. There's going to be integer of 0 to 1, but this is only one character long. Well, char, I'll just have an integer. Cool, so let's have a store, then there'll be a menu. Anything else? Store. Let's actually put the relation on the store, not on the menu, because currently store can't see menu, but menu can see store. But I don't think that's the right way to do it, so we'll do it the other way. So we'll actually move this down here and move this up here, so that the store can reference the menu. Whereas, do we need? Yeah. Actually, we do. Menu, actually we do need this as well. I'm guessing we do, because think about it. I'm guessing we actually do need to do it like this. Because the store, we need to see the menu from the store. That makes sense. But when we're on a menu, I guess we do want to see what store we are linked to as well. For the menu, how do we? Oh. How would I make a menu in a database actually? Because how we have it right now is the menu, and the name, this name is just the name of the menu. You know what I mean? Like, it's just the name of the menu, but I will need multiple items. Like we need items for the menu because a menu typically has many different items. And in our database, how should I model that? Should I have a cell, which is just a list of items? That seems terribly inefficient. But do I have columns for item 1, item 2, item 3? That seems even more inefficient. Why don't we look up? Let's see. How to map restaurant menu in database. This is a good question, actually. There are menu, main. Do I do main, sides, drinks, desserts? I think I should do this actually. Main, sides, drinks, desserts. So there's the category appetizer, main, sides, drinks, desserts. And then people will be able to query by different. And then in each category. But the problem I'm facing is with the category of menu items, which is a second type. Take, for example, a menu deal category to McDonald's, which includes a fries, burger, and drink. This is quite hard. Be in Melbourne, something from restaurant location. You might be able to get a Porsche. ID, meat, cheese, salt, pepper. That's quite hard. I guess what I need is a I need an item table. I'll have an item table. I'll have a, I'm just thinking, maybe, here's my price. So what I guess I could do for this is I can have an item table, PK name, price for this specific item. And then a description, I guess. Description, which is going to be a string. And then below this, I can have an image, which is going to be a blob. And then for the menu, I guess I could have items. Ooh, and it's going to be a list of int, which is a foreign key. Oops, which is going to be a foreign key to item. Now what does this actually look like? So I have item. So I have one table that has all the items. Is that gonna be a performance issue? I'm guessing, would that be fine? I'm guessing, wait, would that be fine? I'm guessing that would be terribly inefficient. lazy loading. I guess I can do lazy loading. Index, we can put an index for the item, but one of the things that could really improve this, I'm guess, is if I actually separate this item into categories. Huh. Let's see. If it is a type of thing, it gets a table. Okay. Is that it? Is that it? Is there anything else I need for item? Let's see. Let's think of a restaurant. Let's think of a place that sells dumplings. Let's think of a place that sells dumplings. So let's say that this dumpling. Whoa. So let's say this dumpling store. There's a dumpling house. They sell dumplings, noodles, fried rice, everything. So we go to the store. The name is ABC Dumplings, and then the menu is a foreign key that goes to the menu. And then the name. Do I need a name of the menu? I don't. There's a menu. There's a store that links back to the store, just in case if I can look up a menu and then I want to find out all the stores associated to it. Wow, okay, that's like an insane join list then. Let's say, what if I want to do something that says, give me all stores that has dumplings in their menu. I'm sure it is possible. It'd be like, select store from store where store.menu.items has name dumplings. I'm guessing, wow, okay, I'm guessing that means I need dumplings. Do I do a string match for the dumplings? Okay, that's also a problem, because like, what if I go to a store and the name of the dumplings is not dumplings? Like, what if they have something else? I'm guessing I need another category for, okay. It's any cuisine as well. Like, what's the cuisine? Country. Okay, let's do that. Cuisine. Or should I put the cuisine in the menu? No, let's cuisine. Let's put it in here. And then let's make a new. How do you spell cuisine? Yeah. Let's have a cuisine. It's going to be a name of cuisine. So like Chinese. Yeah. It's going to go here. Let's think about this. A store can have multiple cuisines. Must it always have a cuisine? It must have at least one cuisine, okay? But again, multiple in a cuisine can have multiple stores, but no. Do I need a table for the cuisine? Yeah. This is gonna be a list of ints. I don't know if this notation is correct, but okay, let's see. Postgres list of integers. This schema. This is having hard to have a list of foreign keys. Postgres. Let's see. So we have a recipe table, which is we have a recipe table, ingredient table, and recipe ingredient table. Okay, so I think I understand this. So what it's saying is I need a third table. So recipe would be my menu, ingredient would be my item. Then my table for recipe ingredient would be recipe ID reference recipe, or ingredient ID references ingredient. Amount? Do I need an amount? Wait, do I need this? This is because every recipe can have a different amount of. I don't need it here. Yeah. Wait, do I need it there? The GPT. Let's say I have a menu table and a items column. I have a items table. Is it fine to have the menu table have a list of integers, which is a foreign key to the column to the item table? Thinking along for a better answer. Is there a better way to do this? I'm guessing, yeah, no. Don't store a list that breaks one database normalization. Model the relationship explicitly. Many to many. So I'll have a menu. ID name. One row per item. That means the menu table is going to be super large. As an m times n rows, where m is the store and n is the amount of items for that store. Oh, okay. So I shouldn't have a list of integers. That's actually really bad. Okay. Ah, wait, that's right. I forgot about database normalization. Database normalization. 1NF, 2NF. Each column contains only a single value. Yeah. I see. So I'm guessing I do something similar for the cuisine thing as well if I do want to have a list. So I'm going to have a separate list. Oops. It was quite similar to what similar to what the Reddit post was about. Menu items. So this is going to be the store. Menu store. I don't even need this actually then. I can just go straight into the menu item. Whoops. Because a store, whoops. Yeah, store is gonna have the PK going into the menu item. Let's look at it here. So a store must have one and only one menu item, but a menu item. Wait, no. Store must have. Can a store have no menus as well? Sure. But a menu item must have each. No, a menu item can have. Yeah, because multiple. Ooh, wait a second. But if in the menu item, if I have a store going to, so my menu item is going to look like, let's look here. So menus and tables, and this is going to be menu ID, item ID. One row per item on a menu. That's what I'm thinking of. If that's the case, if a row exists, it must be mapped to one store. Whereas a store can have. Is my understanding correct here? Wait, is it right? So I have a store table with fields, name, country, and then let's say name and name, country, and a primary key. Then I have menu item that has a PK and store ID. Just store. And store to store. Store has none or many menu items. Menu items has one and only one store. But right now, only menu item can reference store and store. No, reference menu item. Is that fine? Is that fine? So menu item has a store. Yeah. Which makes sense. And then it's gonna have a item as well, which is gonna be an integer to this. I see, okay. And then we'll have the actual item going to the item. So a menu item can have none or many items, but an item must have an item can have none, but a menu item so for each row it has one store and one item. Yep, that makes sense. Cool. Okay, finally I think we've got it. That means we don't need this menu. Oh no, what did I delete? I deleted the cuisine. Wait. Yeah. Okay, then we need to do something similar for the cuisine as well, because a store can have multiple cuisines. Cuisine menu item. Store item. Let's call it store item because menu isn't referred anywhere. So what the store cuisine. Store items. Call it store cuisines. Cuisines integer. No, that doesn't make any sense as well. We need to delete this field. And then here we must have a store of an integer. And then we're gonna have cuisine, which is an integer, where the integer comes here. So cuisine, let's think about this. So a cuisine must have, right, a cuisine can have multiple, okay, this one first, one and only, but this one have multiple. So a row must have one cuisine, but a cuisine can be mapped to multiple stores. Let's think about this. So a store, but a store cuisine must have one and only one. No, actually, because multiple stores can have... No, but then the thing is, I'm mapping it to a store, so it doesn't make sense for a row to have multiple cuisines. Yeah. Okay. Let's see about country, store.country, because a store can only have one country. But then like this. Okay. I think this makes sense for now. What if I... Okay, how is this? Does this mix? Actually, should we not ask GPT? Should I just get with it? Use composite PKs and junctions. For many store items, skip a surrogate serial PK. Make store ID. Okay, so they want me to make this primary key. Okay, so it looks good. So nothing too bad. It seems like, so I'm pretty happy with what we have right now. Okay, so a store is gonna have a primary key, a name of the store, and a country. Country is linked to this. All the items in the store is gonna be found in another table. The cuisine of that store is gonna be linked inside that store as well. Knowing that, why don't we go ahead and map this database out? I think, yeah, why don't we go map this database out? So, putting a VS Code, bigger. Putting a VS Code, we have our compose. have a virtual environment, which we might, let's see. Let's call it, is it init SQL? Let's see, let's look up online. Let's see, new Postgres schema. Docker file. I'm looking to build Docker files to represent. From Postgres, environment Postgres. Do I have a Docker file? No, I have a compose file. How are they different? Docker file versus Docker compose. A Docker file is a simple text file that contains the commands. User would call it simple and image. Example Docker file from Ubuntu, run, add, work. Define multiple. Define the service to make up in Docker compose. The answer is neither. There is no difference. Docker compose will use a Docker file if you add the build command. Your Docker workflow should be to build a suitable Docker file for each image you wish to create. Think use compose to simple using. You can build. Docker file describes how to build. So build the Docker images, while Docker compose is how to run the Docker containers. Okay, let's say you want to build a Docker image that hosts your website on the Nginx web server. To do this, you code a Docker file that instructs you to use the official Nginx image from Docker Hub. Then add a line in your Docker file that copies all of your website files. Yep. For example, once you build Docker images. Okay. But okay, I don't know if I want to do it build time though. Init script. Preceding database with a schema and data for development environment. Ooh, I don't know if I want to do a using JavaScript code. That's not really what I want. I have a standard Postgres. Docker entry point init DB. What is that? Docker entry point init DB. The directory is designed to host scripts. Okay. Do I need a... So for the volume, I just need to copy it over. It into it. And the init SQL will be here. Compose down volumes. Oops, Docker desktop is not running. So if I do that, that should be deleting all. That should... Yeah, let's do create database. Let's call it Yummy. Maybe I do need a better name than Yummy. Let's be a string. Docker compose up. Did it work? Let's see. Did it work? Running Docker point in an SQL. I don't know if that path was correctly read. Oh, wait. If I ever did Docker compose down. Okay. This is happening again. Okay. Okay, so make sure that nothing's running on the ports. Not sure if that is what the problem is. Received fast shutdown request. Logical replication launcher. Ooh, okay, that sounds really weird. But we can connect. Okay, so there definitely is something wrong here. Let's see what's running on the ports. WSL relay. Okay. Well, I have a feeling that my path is actually... Can't really see the path here. Bash? Wait, what would that be for command prompt? Nano? No, nano. Nano? Does nano work? Oh yeah. No. Oh, it is. Okay. Let's see. Why are we receiving a fast shutdown request? Does it say anything? Try docker x docker ps docker. Ah. Ah, okay. So that is fine. Okay. Then why isn't... Yeah, that's what I thought as well, but it doesn't actually exist. I made sure to delete it. Let's try it out here. Oh, it is there. Why can't I see it on dbbeaver? Okay, so it is there. Good. It's because it's empty? It might be because it's empty. Yeah. Whoops. Alright, there we go. Now, okay. So I have to show all databases. That's fine. Cool. So it does work. Just like a little miss. Docker compose down. Docker compose down. Volumes. Can I just do V? No. Okay. Now let's get writing my Postgres ERD diagram. Right. So the first thing is store Postgres. Let's see what it might look like. See it from the actual thing. So create schema creates a new schema. So the first schema will have, let's call it store. authorization role specification. I'll do this if not exists store. What does that look like? Do I need any authorization on this? No. Views, I can do the views later. Not a thing that I think I need to do right now. Cool. So I've done schema. What do I do after schema? So I created a database. Let's create a table now. Create table if not exists. Column data type. Oh, it's not going to be temporary, unlogged. It has to be if not exists. Let's go right into the example. Right, create schema. Do I need a schema? Namespace concept. Why would I need a schema? So server cluster database schema object. Why do I need a schema? Let's read the actual documentation. Postgres database cluster contains one or more named databases. Yep, so one of that is Yummy. Rows a few shared across the entire cluster. A client connection to the server can only access data in a single database, the one specified in the connection request. A database contains one or more named schemas, which in turn contains tables. Schemas also contain other types of objects, including data types. Within one schema, two objects of the same type can have the same name. So do I need a schema? So I actually don't need a schema. I can just go straight into, I'll just have the public schema. So I'm going to have yummy.public, as I don't think I'll be using any data across databases or have any issues with management. So I'll just have the database for Yummy, and then we can create the tables. So create table if not exists. I think that might be a safer one to do. Where is it? If not exists. Yeah, I think it would be good to do if not exists, just to make sure that it will exist. Let's call this one store. Store, that is what I'm gonna call it. How do I? So we're gonna name it store. The first one is going to be the primary key. Let's call it ID. We said we're going to do auto increment for big serial. And this is ID is going to be big serial. It's going to be a primary key. Then the name is going to be a string. Oh, I think it's varchar. Yeah, I think it's varchar. 255. We have not null, so this must always exist. And we're going to have country, which is going to be an integer. It's going to be not null. So integer references, I'm going to do country, ID. And then I have another one, create table if not exists, and then we call it country. Then ID is going to be serial. Primary key. And then I'm going to have name, which is a varchar 255. ISO code, which is going to be a. Oh, can I have varchar? This PostgreSQL extension. I think it'd just be nice to see. All right. It doesn't exist because it's not running. I just want to be able to see that I'm actually writing the right SQL statements. I don't know if I need this. Okay. Does it actually did anything? I'm not sure if it actually did anything. Okay. I don't know if it actually did anything. It's alright. We won't use it. We will just we'll just go with it, and if it complains, then we did not do it right. Let's see. So does Postgres have a char data type? Fix, yeah. So we'll have it to fixed length. How does varchar differ from char? Okay. So varying char and character. We can source up to n characters, not bytes. And it in which truncated. However, if one So it seems like varchar will actually always be better. Okay, but we do know that ISO code will always be 2 characters, so we will be able to just fix it to that. Cool. So let's actually try run that. Docker compose up. All right, syntax error at syntax error. Let's see. Why do we have a syntax error? Syntax error at or near create. Okay. Create table. Is that wrong? Oh. Yeah, let me do a space. Let's try not do the if. No. Create table country. Okay. Why are we complaining? Oh, I need a semicolon at the end, of course. Too much Python. It's no excuse. Relation country does not exist. Okay, I just need to create country first. So delete the volumes. Create database. Cool. Scheme is public table. Ooh. Nothing. Nothing, really. SDB beaver show empty tables. I really want to see just one. Why is it empty? Public. Those not getting created under public. Let's try insert into country. Let's try to insert into country. Values. Oh. Ooh, now I'm actually kind of curious. Is that gonna complain? Ooh. I thought auto increment did. Okay, post, yeah. Pretty sure SQL does auto increment. Now do I have to actually write in? Okay, let's try refresh it. Nothing. Really, nothing. Nothing. Why is there nothing in here? Okay, you know what? I'm sorry. I will try connect to you again. Any localhost? Postgres 54. Yummy. Okay, so I've done that. Can I see it? Oh. Ooh. Okay. Why is it not showing? Incorrect schema. I only have one. I only have one schema, the public. Ah, no, wait. Did I name it? Database. What? Maybe it's yummy database. One. Oh. Wait, it's literally here. What? Okay. I am in public. Yeah. See? I only have one schema. I can't see the tables in it. Database was invalidated. Are you kidding me? I'm literally connected. Whoa. Okay. That's really weird. What's the problem? So in CMD, I can see my table, but in DB Beaver, there is no tables. That's really weird. Why does the Beaver have no tables in it? Maybe I'm not using it right. I only have one. Whoa, 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 whoa. Oh, I'm in the Postgres database. Wait. Wait, I see. Wait, I actually have to use it. Ah, okay. That's crazy. For some reason, I always thought I was. What? That's crazy. Okay. So I actually have to, I've been writing into the Postgres database this whole time. But now if I go in, I'll be able to see it. I see. Damn. Okay. So create database yummy, and then I'm going to use the yummy database, and then we create these into it. Okay. That's fine. Okay, so I've seen I've got it. So I have country. Now let's try to store items. Let's do serial, primary key, and then store. It's going to be an integer reference. Integer references. Store ID. And create table if not exists. Item. The ID is going to be serial. Oh, let's do big serial first one. Big serial, there probably will be a lot. ID. So we're gonna have ID name, which is gonna be varchar 255. This can't be not null. There must be a name to an item. The price. Ooh. Ooh. Okay, so I think I'm using the wrong one. Let's just go to, let's just leave it on small int. Can it be negative? Real. Can I have an unsigned int? Huh. Okay, let's see. Can a meal cost more than 32? Oh, I'm guessing I can actually, because it would be depending on the currency. Like there will be some currencies that are crazy. Let's, integer. How much? What is this? 1, 2, 3, 1, 2, 1 million. Yeah, surely there's nothing that costs like $1 billion. So let's just call it integer. Yeah, let's just have it. Let's just have it as an integer, like the actual cost for the money. Actually, there might be cents as well, right? So we've got to do it to a decimal. We're going to do a float. User specified precision. No, we're going to do it as a decimal. Numeric, how are these different? Numeric and decimal are the same. Okay. Let's say the decimal can be null, just in case we don't know. Description. Let's do a varchar of something big, 9999999. This can be null. Oh, Postgres. How to store images. Okay, so I'll be storing it to a S3. Store it to an S3 bucket. That sounds pretty cool. I just need to see. So Postgres QL table store images. It's gonna be blob for this image. Okay, so it seems like I have to do something similar to what I was doing back here with store cuisines, because an item can have multiple images. Yeah. I guess that's the only real way to have item images. I don't even call it images, I just call it image. So this will have item. Let's be the URL. Delete these two. We're just gonna call it int. So let's think about this. An item can have multiple images. It can have none or it can have multiple. And an item image can only have, must have one and only one item. It's going to be a string. Oh, numeric. Decimal 12. I'm guessing it's telling me to do 12 too. Do I want a timestamp? Okay. I'm guessing I do. Apparently I do. Index. What's the point in creating indexes? Ooh, I did learn about indexes actually. Why do I need these indexes? Timestamp Z is a thing? Oh. It's pretty cool. I think I'll leave this for everything. Damn. So should I have an index on every table then? Do I filter join on it often? I don't think I'll be indexing a lot of images. Or would I be? I need an index. I don't think so. Select all from item image where it would be item image where item is equal to some item, let's say like dumpling. Oh, this is quite bad. Oh. Oh no, wait. Damn, I definitely need an index actually. Damn. Oh, okay, do I have to put a unique in it? Ooh, actually, yeah. Delete cascade. Probably need it. That means when this store ID gets deleted, then this row would be deleted as well. Anything else I need to do? No. Right, store. If the country gets deleted, I don't want to delete it here. If the, yeah, I don't want to delete the store. Do I not want him? Okay, well. I can't have the image inside the item. Because each item will have multiple item images. So the item image. Yeah, like this can't exist here. Item image can't reference because this is going to be a list of integers. I think that's what it was saying. So it has to go here. So an item can have multiple item images. Similar to this, where a store can't have, yeah. Like this. So an item image can have one item, but an item can have multiple. So a store can have multiple store items, but a store item can only have one store. Yeah. Wait, so this is right. This is right. And now let's create. Color item image. the big serial. Store items. This item was a... Wait, if item is a big serial, then store items definitely needs to be a big serial as well. Because even with one store, it's going to be bigger. Yeah. Ooh, hopefully that's big enough. So item ID is going to be an integer. What is a big int? 8 bytes. Okay. Integer references item ID. References item ID and then on delete cascade. Image URL. So bar chart 225. Oh. Position. What is this? This is primary. Do I need a is primary? Oh, and I do need a position as well, actually. Yeah. It's gonna be the position of when it shows alt text. Do I need that? No, I don't think so. So what do these indexes actually mean? Like, provide me with their reason to be here and show me an example. I should probably actually read out about it as well. So I'll write this in for now. So the store, okay, create index if not exist, store item store IDX on store item store ID. Example, select i.i from store items si, join item I, Postgres jump straight to the handful. Show me how the store would be. Okay, so it does seem like, okay, so it helps look up stuff with it. The B tree index. So the B tree index, I have actually learned it, yeah. It is a tree and helps it, so like less goes here, like in between these goes here, in between goes here. Okay, so it just helps it help. Okay, so I actually understand. I don't think I need that one. Let's create these indexes myself. Let's understand. Let's first see when I do actually need an index. So country, I definitely probably do need an index. But let's see what the examples are. For that, with the index scan to the few stores. specifically for the country, show me with real cell data. Can be a table or materialized view, so I'm going to be using a table. Indexes primarily used to enhance data performance, though inappropriate use can result in slow performance. An index view can be B-tree hash. I'm going to be using a B-tree, but that is fairly complicated with a where partial. Okay. To create a unique B-tree index in the column title in the table firms. Let's say I have sample rows. Country, yep. And I have stores. All stores on Canada. No index. So select ID name from store. Select ID and name from store. Country ID is 2. Postgres must scan every row in store. Yeah. Test. This makes sense. Yeah, I completely understand. Result. So create index store IDX on store. Now use the B to jump straight to the country ID equals to range, no full scan. I see. Show me how the indexes are stored in the first country example. Let's use the B-tree example. So because we're using a B-tree, it's going to be 1, 2, 3. Well, I guess that doesn't really make sense for 1, 2, 3 because... Oh. So it only scans the countries within the second one. The children are P2. So 1 goes to 07, 2 goes to 08, 3, 05. So country ID 1 goes to 07, 07, 04. Country. Wow. So with an index, it only looks for its range of that's so much better. So the B tree actually it keeps a record of where it's stored. It has the country ID has a okay, so I definitely need an index then. Okay, what's an unique index? What's the difference? No, actually, let me read it here. Unique closes system check for duplicate values in the table when the index is created. Okay. Ooh, okay. So if I'm creating an index for the country, do I put it on Your store table already has, yeah, references. The ID in the string post unique index. Ah. Postgres already created a unique index. Okay. If it's already made by Postgres, why do I need to create any indexes? Why do I have to create it for other tables then? Country.id, yeah. Postgres does not auto-index foreign columns, store.country.id. Yeah? Country ID doesn't even exist. The country ID is already indexed. So this references that which is already indexed. Okay. Okay. So store references this country ID which is indexed. That's fine. Right, but they always reference the primary keys though. So create index store country IDX on store country ID. Select all from store. What? Okay, so the country in store definitely doesn't need an index then. Postgres, when do I need an index? I have a column that is going to store usernames of users. I notice index. And the search is altered. For example, instead of searching for it, select all from table where username is used, you search for. We create index for two reasons: to enforce unique constraints. Okay, to enforce unique constraints, and to improve performance and reduce contention. When we declare a unique constraint, it's unique. When we look up a word in the dictionary, Oh, really? These should match. Are you supposed to match exactly? Okay. I don't know. I don't know if that actually mattered, but sure. Okay, you know what? I will create an index on okay, I'll create a one. Yeah. Because I might want to see this makes sense, you know, if I have like there's ever a case that I want to look up, like yeah, I'll have an index for that. I'll make it unique as well, because we do want that to be unique. Index on the foreign key, you'll filter by the most. Country ID. If you often list stores by name within a country, use a composite to also cover the short. Create index on store country ID. So this doesn't have an index right now. Select ID name from store. Okay, then we're changing this to ID. So I'm going to change that to ID. Select ID and the name of the store from country ID equals to order by name. So let's say I'm trying to get all the stores with a specific country ID. Okay, so this is a good one. Country table ID. I see. So this is indexed. Yep. So this is indexed. So when we join store, okay. Okay, so I get it. If we do the join between the store and the country, then we're going to use the country table ID is already auto indexed. So most real queries, the join touches both sides. Really? Start from country, get its stores. Okay, so it actually does need both. Damn. Country.id is the store. Since your query filters on and orders by store name, you should add an index on store to match that pattern. Because you often sort by name within a country, make a composite B tree. Create index concurrently. Ooh, I don't think we wanna. Do we want to return it alphabetized? I see. So on country it makes sense, but then on store, do we want to index the store? Yeah, we should be doing a lot of this. So every time we're trying to join the country and the store, the country is, you know, nice and indexed, so it's nice and easy to see. But then the store.country ID, it's never indexed, so we have to scan through all of the store. But we don't want to do that. So let's actually create what is index indexing by the name. I see. So I should be indexing by, yeah. Let me just read it here. And this postgrad will build the index without where's the stand index? Okay, I don't want to use concurrence currently. Okay, so I won't be using concurrently actually. Store country name IDX. Yeah, it's unique IDX. Store, it's going to be ID and then name. Okay, cool. Let's see what other indexes do I need? Do I need an index for store items? Damn. Okay, so it seems like I need an index for all my tables then. Seems like all of my tables can actually help from index. Ooh. Okay, let's go through it together. Let's look at store items. I'm guessing I want an index for store. Do I want an index for item? Let's say I want to get, probably not for item. So I think I do want an index for store. I want to be like, get all the items within this store, and then the index would be helping for that. But get all stores with item. Ooh, I guess that can actually be pretty good as well. Creates a B tree index with. Oh, the unique already makes an index. Okay. Create speech with stores to live. So let's think about when it help. Index on store ID would help when we are looking for a store. Index an item would help when we are looking for stores that has item X. Okay. So this is going to create a... How do I do a comment? Oh. ID and item ID. All stores within a country. What does this index help? Store index helps with getting with so it's sorted when it gets stored. Store items. Okay. Now let's look for item. So ID is already indexed. Name, do I have to do? Actually, price could be pretty useful. Wait, I think this is a trap. I am indexing everything. Okay, so I indexed these two. I indexed price. Let's look at item image. So item ID, URL, it's going to be a string. Is primary. It's going to be a bool. And then position. It's going to be an integer. And let's try to do item image. So item ID probably needs to be indexed. And only that. Do I even need an index? In order. Do I need an index for item ID? Like every time I will be looking at the item image, it would be through the item, in which a join with item will be made. I don't think I actually need it because item and an item image will always be joined. And then that means when you run II from item I, yeah, join item I. I see. Do I need an index on countries then? Huh. Items. Okay, like store. Okay, I'll leave the indexes for now. I don't actually think I need these indexing for the future if required. I don't think I actually need these indexing. Let's just go back. Let's just go back to. Yeah, I don't think I think I spent too much time on the indexing when I actually didn't need it. But it's alright. Let's go back to creating the table. You know, I don't even need this. because this will only run the very first time Postgres anyways. Let's call it cuisine. Then we're gonna have ID serial, which is gonna be the primary key, and the name varchar255. We can have a created add as well, which is quite cool. And then create table, store cuisines. I guess this is more like who owns it. ID is going to be serial, primary key. Store is going to be a big int that references store ID. It's going to be store ID. And then cuisine ID, which is going to be a serial. What is serial? Serial 4 bytes. That's going to be an integer.
I found some web results. I can show them if you ask again from your iPhone.
Okay, that was Siri. That kind of scared me. That references cuisine on ID. We'll have a created at column as well. That defaults to no. Okay. Everything else is big serial. Oh, item image is big serial as well. Let's change it to that. Serious, this is going to be an int. So if you go to store, country ID is going to be an integer. Cool. And my last one is user. Yeah. So create table users. ID is going to be big serial. Primary key. Name is going to be a string. Let's have a limit of what? How many characters? 255 characters. Username is going to be unique. Try 255. Default country. It's going to be not null. This references country ID. Wait. Where was my cascade item image? So if an item deletes, I need all the images gone. If a cuisine is deleted, do I want all the stores deleted? No. If a country is deleted, do I want all the stores deleted? No. If item is deleted, I want all the images deleted. Yes. If a cuisine is deleted. Okay, wait. Okay. If a store is deleted, I don't want the country to go. I want this one to go, and I do want that one to go as well. If the cuisine is deleted, actually not sure. When should I cascade on delete? Yeah, I would just do it. You know what? I'm just going to do it. If I have an item and I delete the item, I want the images gone. If I delete the item, I want... do I want the images gone? I mean, they'll still be in S3. But what if I, ever come back? Oh. Okay, if I have an item and I delete the item, do I want to delete the images of this item? Yeah, of course I do. I think. Ooh. Wait. All right. Let's talk about cascade delete. Item has item image. Delete an item. Deleting. Oh, I don't know. Do I want to keep it? I'm thinking, do I want to keep it or do I want to delete it? If I delete a store, do I want to delete all the items for that store as well? Okay, but what? Even if it's the same item, the item primary key will be different. I guess, yeah. Even if I end up deleting it, if I end up deleting the item and I rebring it, there's no way to actually map the item image to that item new primary key as well, because the existing item ID in the past and the new item ID will be different. Yeah, that makes sense. Okay. Okay, same thing for if you've gotta. Okay, I'll do cascade, but to be honest, for now, I don't think I'll have the option of deleting stuff. Let's say I made a store. Yeah, okay, no, this makes sense. So I made a store with an item, but I have the wrong item in the store. So I delete this, I made the store completely wrong, then I delete it, then everything in the item should be deleted as well. I shouldn't be able to like move a store into another store. Like, yeah. And then for cuisine, let's think about cuisine. If I delete... Oh, for cuisine, I don't think it's actually quite right. Oh, okay. Oh, not for cuisine. No, definitely not for cuisine. What was I thinking? So a store item can have multiple items, but ultimately it's tied to a store. But a store can have multiple because oh no, this is bad. If I delete a cuisine, if I delete a store and it deletes the cuisine for one, it's going to delete all the cuisine instead of stores as well. So I don't want to do that. Okay. So item, image, item. Yeah. I should definitely leave it there. Yeah. And then password. Wait, this Postgres unique and not null. Okay, well, I'm guessing it can't be unique and null at the same time. That doesn't make any sense, but I'll just write it like that anyways. Password doesn't have to be unique. It's going to be a varchar 255. Need to add salt. And a hash and salt. I think I add the salt here as well. Pretty sure the salt comes into the database. Not too sure. Is this how it's done? I'm pretty sure I store the salt in the database. When it comes to it, I can do it, but the password's not even going to be not a thing yet. It's not going to be a thing yet. The email. Not a thing yet as well. Okay, cool. So there we go. This is our basic thing. Let's try and run it. Docker compose up. Store items. What's wrong on store items? Create table item. I never added the semicolons. What a rookie mistake. Let's try that again. Table users. not novelchar. Oh. Yes, I'm quite sure the type needs to come first. And then... Wait, is it? Yes, you did come. Okay. Okay, I'm looking for an example, but yeah, it does come after it. So it always comes. Default country is an integer. Password varchar. Oh, it's because I have that last comment there. So if I do run. Okay, now it's up and running. If I reset this, I have country. Oh. Yeah. So I have country uses. That's because it has the most amount of fields, I'm guessing. Four plus 8 plus 4. Okay. Okay. How are these actually defined? Okay, very cool. Okay. So I've done it. I've done it for one. Let's commit this. Add init SQL for store, menu, cuisine, country, and users. Country, menu, images, and user. No! Git commit. That's not how you do a git commit. Okay, never knew that actually mattered, but I guess it did. Am I not in Git? Pretty sure I am. No config created push destination. Huh. Huh, wait. Wait. Something is wrong with my Git. Okay. Seems like it actually wasn't. Seems like it actually wasn't tracking my Git for some reason. Anyways, that's fine. Okay. But we do know that we have set up a initial init. Oh. Okay. I just don't know what happened. Okay. All right, there's something wrong. Something terribly wrong with this. So what I'm gonna do, what I like to do, is I'm just gonna delete the whole file. And then I'm just gonna clone it. Okay. Really? How do I CD into that? It doesn't really matter where I CD into, but I'd rather CD into into my desktop. So let's try to do that. Okay. I CD into my E drive? Ah, okay, very cool. I just do that. Just do E dash, no CD. Coming into Yummy, and then I'll go into Yummy. And then get branch A, get checkout develop. Okay, cool, good. Well, thank you guys for watching this new episode. Catch you in the next one.